Okay, 7.3, solving linear systems by linear combinations. The objective is students will be able to solve a linear system by not substitution, actually. It's elimination. Okay, before we do example number 1, I wanted to show you something. Let's pick 3 numbers here. I don't know, 7 plus 3, that equals 10. Let's do like 5 minus 4, that would equal 1. So I have 2 equations. If I was to add these straight down, 7 plus 5, that would be 12. 3 and negative 4, that would be negative 1. And 10 and 1, that make 11. What do you know? 12 minus 1 equals 11. Okay, let's try something else here. Interesting. Let me get rid of this. Let's pick some different numbers. Okay, let's say I was going to do, I don't know, 17 minus 9. Well, 17 minus 9, that equals 8. Let's do 13 plus 6, sure, equals 19. Okay, let's go straight down. 17 plus 13, well, that's 30. Negative 9 and positive 6, that makes negative 3. And 8 plus 19, that makes 27. And what do you know? 30 minus 3 equals 27. So it doesn't matter what numbers you use. This will always work. You can always just kind of add straight down. So we're going to use that concept in dealing with linear systems. So here we have an equation, or we have 2 equations rather. 4x plus 3y equals 16, and 2x minus 3y equals 8. And we're going to try and solve for x and y just like we've been doing, but now we're going to add these equations together in the same way that we did. And before we add it together, though, the purpose in doing this is to try and get some variables to cancel out. And you notice here I have a positive 3y, and here I have a negative 3y. So when I add these together, I'm going to just get a 0y, or 0, because 0 times y is just 0. So that gets a 0. Over here, I have a 4x and a 2x, that makes a 6x. And 8 plus 16, that makes 24. So really, this is just 6x equals 24. And now I have an equation that's solvable. That's why I did this, because I wanted these 2 things to cancel out. If I don't get a variable to cancel out, there's no point in doing this. So that's what I'm going for. So lastly, I'm going to divide everything by 6, and I get simply x equals 4. Pretty simple. And then I'm going to take this and I'm going to plug it back into one of these original equations. So I get 2 times x, but instead of x I put 4 minus 3y equals 8. Okay, 2 times 4 is 8 minus 3y equals 8. Subtract 8, that cancels, and this actually cancels too, giving me negative 3y equals 0. Divide by negative 3, divide by negative 3, and we just get y equals 0. So there's your answer, 4, 0. Boom. So we can just add straight down and get it to eliminate. All right. I want you guys to do that with these equations here. So I have practice number 1. You can see when you add straight down, these guys should cancel. Part B, when you add straight down, the y's here should cancel because you have a negative 2y and a positive 2y. And when you add straight down here, your x's should cancel. So do that. You're going to solve for one of the variables, and then you're going to go back and plug it back in. So go ahead and try that. I'd pause the video because I'm going to put these up in a second, and you can check your work. Okay, here's the answers that you should have got. For this one, you should have got, zoom in here, you should have got 1, 2. For this one, you should have got 2, 3. And for this one, you should have gotten negative 2, 3. So, there's all the answers. If you didn't get those 3, you're going to want to try it again, see what you did wrong. Yeah, figure it out. Okay. Now let's go on to example number 2. Notice in example number 2, we don't have one that just automatically cancels out, right? If I was to add this straight down, I'd get negative x. It wouldn't cancel out. I'd get 7y. It wouldn't cancel out. So we need to do something to it first to get it to cancel out. So what we do is we multiply the whole equation by something to get it to cancel out. Well, I have a positive 3 and a negative 4. If I want these two things to cancel out, I want to see what I can multiply by so that these two would get to the exact opposite numbers. And 3 and 4 both go into 12. So I'm thinking I can multiply this by 4 to get a 12x, and I can multiply this by 3 to get a negative 12x. So that's what I'm going to do, but I'm going to do the whole equation. So let me show you what I mean. I'm going to do 4 times 3x, and that's going to give me 12x. 4 times 5y, that's going to give me 20y. And 4 times 6, it's going to give me 24. And now I'm going to do the same thing with the bottom one. 3 times negative 4 gets me negative 12x, which is what I wanted. 3 times 2y gives me 6y. And 3 times 5 gets me 15. Okay? Let's add these equations now. 12x minus 12x just gets a good 0. That's nice. 20y and 6y gives me 26y. And 24 and 15 make 39. Okay. I'm going to divide both sides by 26. Divide by 26. This cancels. And I'm left with 39 over 26. Well, I can actually reduce that. If I wanted to, I could take y. Let's put it over here. 39 over 26. I can actually take a 13 out of both of these numbers. So 39 divided by 13 is 3, and 26 divided by 13 is 2. So there's my answer, 3 halves, or you could say 1.5. It's the same thing. So there's my y. Y equals 3 halves. Alright, well, let's take that, and let's plug it right back into one of the original equations. I recommend doing the original equations just because they're usually simpler. You could plug it into one of these guys over here, but usually these are the simpler ones to use. So let's do that. I'm going to do it in blue. So negative 4x plus 2, and instead of y now, I'm going to do 3 halves equals 5. So negative 4x plus, what happens when you multiply these guys together? You get 2 times 3 halves. Well, this is kind of like 2 for 1. And when you're multiplying fractions, you can just kind of let these guys cancel out or reduce down to 1. And so you're left with just a 3 equals 5. Subtract 3, subtract 3. And you get negative 4x equals 2. Divide by negative 4, divide by negative 4. And we get x equals 2 over 4, or negative 2 over 4, which is the same thing as negative 1/2. And so your answer here would be negative 1/2, comma, 3 halves. Boom. Okay. So remember, the trick here was finding that number that we would multiply both by to get them to cancel out just perfectly. And I have some practice problems here. Notice I canceled this one out because it just doesn't work very well. So we're going to just do A and C. So again, why don't you pause the video or go back and watch it again if you need some extra help. But pause the video and try practice number 2. Okay, when I did this, I had 2, 0 for this one, and 1, negative 2 for this one. Okay, let's go on to the next problem, which I believe is on the next page. Okay, so this one is a little bit different because now not only are we going to have to multiply things, but also look, everything's in the wrong order. So what we got to do is we got to get it all on the same side so that we can't add the equation straight through. Otherwise, it won't really work because we won't be able to combine like terms. So let's zoom in here. 3x plus 2y equals 8. Well, that looks like the form that we're used to. That's actually standard form. But this is not at all in the normal form. So we need to try and get it to look like that. So let's do a little work with it over here. I'm going to kind of just do a little arrow. So I got 2y equals 12 minus 5x. Well, first of all, I need to get that 5x to the other side. So I add 5x to both sides, and I get 5x plus 2y equals 12. Well, now look at it. I got an xy, then a number, xy, and the number. So looks like I'm in good shape. So I'm going to bring the other one over here. It was 3x plus 2y equals 8. Okay. This one, we're not going to have to multiply it by a big number because look, 2y, 2y. Now they won't cancel each other out, but what we could do is we could just multiply the bottom here by a -1. A -1. And now if I was to put that -1 and distribute it all the way through, here's what would happen. I'm going to undo what I just did. This would end up being -3x, -2y, and -8. So it's like we multiplied everything by -1. Okay. Well, if that's what I did, and then I added these together, I'd get 5 minus 3x, which is 2x. And I'd get 2y minus 2y, which is just 0. And then I get 12 minus 8, which is 4. So 2x equals 4. Divide both sides by 2, and I get x equals 2. All right, that's easy enough. Let's take this, and I would actually plug it back into this equation right here. So I get 2y equals 12 minus 5 times 2. All right, 2y equals 12 minus 10. And 12 minus 10 is 2. And 2y equals 2, so y must equal 1. So my answer would be 2, 1. All right, so that time the trick was we needed to get it in the right order and then just multiply by a -1. And we got something to cancel out. So we're always looking for what's going to be the easiest thing to just cancel out. And in this situation, subtracting one equation from the other was the easiest. All right, so once again, I have some practice problems for you. I crossed off C again because I think that one's probably not going to work so well. So I have 2 here. I'm going to do them. So I would pause the video, and the answers will be up on the screen shortly. So you want to work them out on your own while before you see the answers. Okay. Okay, here's the answers I got. I got 2, -3, and -1, 3. And that's what we should have got for your answers. If you didn't get that, check your work. You could kind of just maybe pause this and zoom in on my work. And, yeah, I'll zoom in on both of these just so you can kind of see them. Kind of see what I did. This one, I had to multiply by 3 and by 2 to get it to cancel out nicely. But it does work. All right, that's it for 7-3. See you guys next time on 7-4.